Tanisha started her homework immediately after class, but had more to finish in the evening. When she started her homework at 7 p.m., she tracked how many problems she still had to complete. The information she collected is shown on the table below. So here we have the time, and here we have the number of problems still to complete before she was finished. So we're going to let M be the number of minutes past 7 o'clock. So let's just mark that as we're reading through. M is number of minutes past 7. And P, what's that going to be? P is the number of problems Tanisha still needs to complete. So number of problems, and we want to keep track that that still needs to complete, not the ones that she's already done. So we're going to create a scatter plot of this information and draw a line that comes close to the points. And then we're going to talk about the M-intercept and the P-intercept to see what that information gives us. So let's create our scatter plot here. So I've already started with my coordinate system. I know that the time information is going to be my independent variable because it comes first. And the number of problems still to complete, that's going to be my dependent variable. And what variables I'm going to use are given to me here in part A, as well as what labels I need to put on my set of axes. So all that information is given to me in the Word. So we just read that carefully and be sure that that gets transferred down. Sometimes it's helpful to actually write down on our table that this is the M information, this is the P information. But we do have to be careful of the M because we're not going to be using these numbers. We're going to be using the number of minutes past 7. So in this case, 7 o'clock would be 0 minutes past 7, so M would equal 0. At 7:15, M is going to equal 15 because that's 15 minutes past. And then at 7:30, we're going to be at 30 minutes past. And then 7:45 would be 45 for M. And then once we go to 8 o'clock, that's 60 minutes past. And then another 15 minutes to get to 8:15 is going to be 75. So those are the values for M we're going to need to be plotting. And then these are the actual numbers that we'll use for P for the number of problems still to complete. So I've started out on my coordinate system. I've got my variables in place. So notice that there's the P for the number of problems still to complete. And here's my M down here. And that M represents the minutes past 7 p.m. And so now we just need to work on what our scale is going to be. So for my time, I need to go all the way from 0 to 75. So depending on how many lines you have, you might be able to go by fives. Notice that to go by fives, we would need 15 lines because 15 times 5 is 75. Unfortunately, on my graph, I only have 14 lines, so I'm not going to be able to scale by fives. So if scaling by fives doesn't work, kind of the next default that we have is to go by tens. So I'm going to scale by tens. So here's 10, 20, 30, 40, 50, 60, 70, 80, and I'll go out to 100, even though we know the highest value that we're going to have to plot um, is 75. Okay, so there's by going by tens. In terms of how many problems I still need to complete, I go from 24 all the way down to 0, so I have to get all the way up to 24. Now I know I don't have 24 lines on my vertical axis, so I can't go by ones, but I know that I have more than 12, so I can go by twos on my vertical axis for my scale. So once again, we're using a different scale on the vertical than we are on the horizontal, and that's okay to do, as long as within each axis we're staying consistent with our values. So let me go ahead and get the number of problems still to complete. We're going to scale by twos. So here's 2, 4, 6, 8, 10, 12. Again, just labeling every other line. I'm still scaling by twos, but just labeling every other line. There's 14, 16, 18, 20, 22, 24, 26, 28. Okay, so there's our scale. Everything is labeled as it needs to be, so now we're ready to plot our points. So we know when M was 0, we were at 24 points. or 24 problems still to complete. So that's going to be right here on my p-axis, where I'm at 0. When m is 15, we had 20 problems still to complete. So I'm going to need to go down and see where 15 is. So remember, here's 0, 10, 20. So 15 would be halfway between the 10 line and the 20 line. And if I go straight up to 20, because there were 20 problems still to complete, that's the 15-minute mark. Then at 30 minutes, we had 15 problems still to complete. So at 30 minutes, so here's 30, we said we had 15 problems still to do. So there's 16, there's 15, because halfway between 14 and 16 is the number 15 right there. Okay, so there's that point. At m equals 45, we're down to 11. So when m is 45, so here's 45, halfway between 40 and 50. M is 11, so that's going to be halfway between the 10 line and the 12 line. So that's going to be right about there. Again, we're just doing careful estimations. When m is 60, we have 5 problems left. M is 60, we've got 5 problems. Well, here's 4 and here's 6, so we're going to be halfway in between. And then by the time we get to 75, that's when we hit the 0 point. So here's 70, here's 80, 75 would be halfway across, and at that point we don't have any problems still left. So notice we've got something that's close to linear, but not quite. So let's go up and get our straight edge so we can draw a line that comes close to our points. So we're going to grab the straight edge, and we're going to bring that down here. And we're going to line it up on this first point here. And then we're going to just scroll down just a little bit, and we're going to pivot that straight edge just like you would do if you were working on your own paper. And I'm going to say right about there, I think, is kind of how I want my line to be. I could shift it just a little bit maybe, because I want to have as much above the line as I do below the line in terms of the ones that don't fit. So I'm going to go ahead and do it right about there, I think. Oh, it just smidged up. So let me just kind of reestablish that. I think I like how that looks right there. Now notice this doesn't go through every single point. Sometimes our models don't. That's why it's called a model. If it was exactly linearly related, it would go through every single point. But in this case, it doesn't. So let's go ahead and draw our line like that. And then once we've done that, we're done with our straight edge. And so we can make that go away. So that's where our points. Now notice that something kind of weird has happened. I'm actually going to get rid of this part of my line that comes down here below, because it doesn't make any sense to have a negative number of problems to complete, right? So I just wanted to get rid of that little extra bit of my line there. And I'll get that 80 back into place. Now notice that by finding a model, it changes what happens with my intercept. That the intercept had been here, but it kind of smidged over when we tried to come up with a model. So be aware that that's sometimes going to happen. Notice that these questions are asking us for the intercepts of the model, not for the actual points that we plotted. So once we've created our linear model, now we're going to answer the questions based on the line, not on the actual points. So when it asks me for my m-intercept, when I take a look at where my m-intercept now, it actually looks like it's at about 79, 0. It's just a little bit less than 80. So my m-intercept is going to be at about 79, 0. That's the ordered pair that is the intercept. Remember, intercepts are an ordered pair. What information does that give me? Well, 79 was at the minutes past 7 o'clock. So at 79 minutes after 7, and then we should say, well, that seems really weird to say it that way. We should say what time that is, and what time at 79 minutes after 7 p.m. That would be 8:19. Tanisha was done with her homework. So Tanisha finished homework. And notice that we're not necessarily using the word zero. We're not using that number. We're saying, what does it mean to say she has zero homework problems to complete? That means that she's done. So, how we put meaning to this doesn't, we have lots of ways of using our language to talk about what these numbers are going to mean. Then, when we talk about the p-intercept of the model and what that information gives us, well, the p-intercept of the model, my model does in fact go right here through 0, 24, or 24, 0, no, 0, 24. See, sometimes I get those mixed up too. So I went nowhere in the horizontal direction and I went up 24 in the vertical. So that's going to be at 0, 24. That's my p-intercept. What information does that give me? So that just tells me when Tanisha started at 7. So that's when she started, right at 7 o'clock. So when she started at 7 p.m., she had 24 problems to complete. So 24 problems to do. And again, lots of different ways we can use our language to give meaning to these points. But that's the whole point of doing this, is that we want to give meaning to the work that we're doing. Otherwise, math really isn't very helpful if it doesn't have any meaning for our everyday life. That may be hard to believe, but it's true.